welcome back. We will discuss a few more problems on nodal analysis. In the last lecture also, we have discussed a few problems on nodal analysis, and we will continue the same. We will be learning how to determine the node voltages, branch currents, and also voltage drops across various elements using nodal analysis. So, I'll once again start with the steps which are involved in nodal analysis, and then we will do some problem on nodal analysis. So the first step is identifying the number of nodes and then assigning them voltages, and then we will apply KCL, and then we will solve those equations, and finally we will try to determine what actually is required from the given circuit. So the problem, so this is the problem which is given for you. Find the current flowing through the 8 ohms resistor using nodal analysis and calculate the power dissipated by the 8 ohms resistor. So this is the circuit which has been given for you. You need to determine what is the current which is flowing in this 8 ohms resistor and the power which is dissipated by the 8 ohms resistor. And all these are resistors with values of ohms. So there is a voltage source present here and there is a current source also present here. So try to be very careful. When there is a current source in any path, the current I will directly take it as 4 amperes. If it is not available, I will take it as V start minus Vn by resistor. If directly current is there, I will directly take the currents. Okay. So now, if you carefully see, first of all, our first step is identifying the nodes. See, this is 1, this is 1, this is 2, this is also 2, there is no change, and here this is 3, all these things they are 3, and again here this is 4. So there are 4 nodes, 1, 2, 3 and 4. And out of these 4 nodes, see, I'll check this one as 0 volts. So if it is 0, then automatically there is a potential drop here, right? So automatically this will become 12 volts. This I don't know, I'll take it as V1. Here I don't know, I'll take it as V2. And this is not a voltage source to get it back here. This is a current source. So only voltage ought to be mentioned here. So V1, V2, 12 and 0. Right. So this is here V1, V2, 12 and 0. Done. So I'll mention here, this is V1, this is V2, this is 12 volts and this is 0. So now I need to apply KCL at each of these effective nodes. So I'll take this first node now. How many paths are there? 1, 2 and 3. So the first path from here, V1 to, what is the nearest node? 12. So V1 minus 12 by resistor is 2 ohms. And the second path, V1 to, the next one is 0 by 4. And the third path, V1 to, the next one is V2. You solve this equation and you take the LCM is 8, you solve it, you will get this equation. Similarly for node number 2, this is node number 2, V2. This was V1, this was 0 and this is also 0, right? So again, how many paths are there? 3 paths are there here. So the first path, V2 to V1, V2 minus V1 by 8 plus the second path, it is V2 minus 0 by 2, and this is the third path. Actually current is directly given for you here, 4 amperes, but actually it is incoming, but your direction must be outgoing, so I'll take it as minus 4 is equal to 0. This is what I have written here, right? You take the LCM, you solve it, you'll get this equation. Now I do have 2 equations now. This is my first equation, 7V1 minus V2 is equal to 48. This is the second equation. Now you solve these 2 equations, you will get V1 and V2 values. See, V1 value is 7.294 volts and V2 is 3.059 volts. The distance. Now, step number 5 is about what you want actually. What you want actually, the current which is flowing in this one. So what is the current which is flowing? It is V1 minus V2 by resistance. Right? What is V1 minus V2? It is 7.294 minus 3.059 by what is the resistance value? 8. So you will get somewhere around 0.5295. Then also they have asked you to determine the current, power. So what is power equation? I square into R. So I'll get 0.53. This is 0.53 approximately, right? 0.53 whole square into 8. Whatever the value, I'll take it as watts. Understood? So this is the way how we solve the problems using nodal analysis. I hope that you are now able to determine the nodal analysis. You are now able to apply nodal analysis for determining the node voltage, branch currents, and branch voltage also. So this is a problem for you. Determine the current in the 1 ohm resistor. So this is 1 ohm resistor using nodal analysis. See how many nodes are there? So I'll take this one, this one, this one is all 1, right? So I'll take this one as 2, I'll take this one as 3, and I'll take this one as completely 0, right? This is 4. You can take any of these things as 0 volts. So I'll take this one as 0 volts. And if it is 0, then automatically this will be at 2 volts, right? The rest, there is no voltage significance here. So I'll take this one as V1 and this one as V2. And then you can try to solve. You do have 2 effective nodes now. At this one, how many paths you do have? This is 1 path, this is 2nd path, this is 3rd path, and this is 4th path. So 4 paths are there at node 1. And at node 2, 1, 2, and 3 paths. You try to solve them and determine the current in 1 ohm resistor. So what will be the current in 1 ohm resistor? It is V1 minus V2 is the voltage drop by resistance is 1. This will be the current. Once you do have V1 and V2, you can solve the current in the resistor. So that's it from my side. Thank you. We'll solve more problems in the class. Come prepare for the class. Okay. Thank you.